everybody, and welcome to the world of weather. I'm so excited about today's lesson because it's about earthquakes. It's something you hear a lot about on the news, especially in California where they have a lot of earthquakes. But actually, did you know there's more earthquakes in Alaska than there are in California? We're going to talk about fault lines. We're going to talk about earthquakes here in Georgia, what we see here in Georgia, and we're going to talk about how they form, where they form, how strong they can be. So if you've ever been interested in earthquakes, this is the lesson for you. If you have any questions, please feel free to ask them right now. You can just type them in at the bottom here on this Facebook feed, and we're going to answer those. So any questions you have along the way, please ask them, and maybe I'll answer them as we go along. So let's start with my globe. I never thought I'd be using my globe so much because the key to earthquakes is the Earth's plates. So the Earth is round, but the Earth is actually made up of various plates that are all touching around the entire globe. It's almost like you have a cookie and pretend you break the cookie and how there's these little cracks in the cookie. Even though the cookie's in one piece put together, there are cracks in the cookie. So the earthquakes happen along those cracks, and those cracks on the Earth's surface are called fault lines. And that's where we see the earthquakes happening along those fault lines. And the closer you are to those fault lines, the more earthquakes you're going to see, the stronger the earthquakes you're going to see. There's actually a really big fault line right along that almost travels right along the Pacific coast, right there on the edge of California, then goes up through the western side of Canada, and then on the south side of Alaska. So Alaska has the most earthquakes of anywhere in the United States, and the strongest earthquakes are in Alaska, but it's along that fault line right there, right along the Pacific. It divides the Pacific plate and the North American plate. So that's where we see most of the earthquakes. But we have some fault lines across the U.S. as well. So we're going to be talking about that as we head through. First, a quick little lesson about what is an earthquake. Why does it happen? An earthquake is when two large pieces of the Earth's crust suddenly slips. And what happens is it causes shock waves to form, and you feel it as an earthquake. So here's a little example. This is my daughter's little play cake that she plays house with, but there's little pieces of Velcro on here just to kind of show you what it is. So you have two plates, and let's say they're starting to slide apart, slide. All of this tension builds up, and all of a sudden when it does break apart, that tension builds up, and that's when you have those earthquakes happen. So they happen on the edges of large section of the Earth's crust. They're called tectonic plates, the edges here of the Earth's crust, where we get that friction and we get that happening. They move very slowly over a period of time. So this isn't a quick action that happens. These are actually moving all the time. They're just moving very, very slowly. But as they're moving, you get that pressure start to building up. And when that pressure releases, that's when you get an earthquake. Now, there's also foreshocks and aftershocks. So you're going to hear about those as well. Foreshocks happen before an earthquake. Aftershocks happen after an earthquake. Now, sometimes foreshocks, we don't realize it's a foreshock. We think it's the actual earthquake. Really, there's no way to know if it's a foreshock or an actual earthquake. You almost have to wait for the actual earthquake to happen to realize it's an earthquake. The aftershock are the smaller earthquakes that happen after the initial earthquake. So that's why sometimes after an earthquake, there's additional earthquakes. Usually they are a little weaker. Seismic waves, that's what we use to measure these earthquakes. We use seismic waves. The higher the number, the stronger the magnitude earthquake. And I have a graphic to explain some of that in a little bit, but I just wanted to give you an idea what those are. So let's see. Big question is, can scientists predict earthquakes? I wish scientists could predict earthquakes. We know where they are most likely to occur. We know where the strongest ones are most likely to occur, but scientists cannot predict exactly when an earthquake is going to happen. So that's why they happen so suddenly without warning. If we get a foreshock, we know it's coming sometimes, but there's no real way to predict an earthquake. It's very different than a hurricane where you know it's coming, or a tornado where you can't exactly predict it's happening, but you know that the environment is favorable for a tornado to happen. So again, plates on the Earth make up the Earth. When they slip and slide past each other, the tension builds up, and that's what causes an earthquake to form. So I want to show you something here. Let me get this. This is from the USGS, so the United States Geological Survey, and it pinpoints the highest hazard of earthquakes. So let me flip this around here. see where it is. Now, I'm showing you this because, again, remember we talked about that big fault right along the edge of the United States, right along California, up through Oregon. Notice that's the highest hazard. So we have a high hazard there. That's where the major fault is. The San Andreas fault happens right around there. But even as we head towards Western Kentucky, Western Tennessee, certainly there's some high activity along a fault line there. And then you look at North Georgia, and we are close to a fault line right there across eastern Tennessee, but we're far enough away that by the time we feel the effects of these earthquakes, they're very minimal. So yes, we get earthquakes in Georgia, but they're not nearly as strong as they would be in eastern Tennessee, western Tennessee, or especially as you look at southeastern Missouri, where it's the highest risk. So we're going to get you to our lesson for today, and that is earthquakes. So this is helping explain a little bit about what I just explained, and that is before an earthquake, you have the tectonic plates, you have that fault line we talked about. So the fault line, imagine it's that crack in the cookie. So you have two plates, you have a crack in the middle, and when they slide past each other or next to each other, they create an earthquake. We use magnitude to measure how strong an earthquake is. There's magnitude 2, there's magnitude 3, there's magnitude 4. Earthquakes. So magnitude 3 and lower is very minor. You normally don't even feel it. It really doesn't make an impact at all. It's a very weak earthquake. The higher the number, the stronger the earthquake. And they'll have a point. So you'll hear a 4.7 magnitude earthquake or a 3.6 magnitude earthquake. So the higher the number, the stronger it is. Once you start getting into a category 6 or higher, that is a strong earthquake. That's when you get property damage likely. There's only about 120 strong magnitude earthquakes per year, and it is very, very destructive. You're looking at the energy equivalent of 33 million pounds of explosive. Once you get into a 7, an 8, a 9, I mean, you're talking about catastrophic damage, especially a 9, near total destruction. You only get one every 10 years or so. Doesn't happen very often. So that's the good news with it. But when you look through history, the strongest earthquakes are obviously those that cause the most damage. But the stronger the earthquake, the less we see it. When you look at those magnitude 3, magnitude 2 earthquakes, notice how often we get them. I mean, we get 1 million per year of magnitude 2s. So we're always getting a little bit of movement in the earth. That's normal. Seeing a 2 or 3 is not very destructive. It's those stronger earthquakes that cause the most damage. Now, I do want to talk about a dormant fault zone because we actually have a fault zone here right along Georgia, and it really goes right along where Georgia 400 and 285 meet. And it continues through Cobb County, and then it continues right along the western side of Fulton County to Carroll County. Actually covers some of Alabama and North Carolina, and it's called the Brevard Fault Zone. And the Brevard Fault Zone is 100-mile long, inactive fault line. So inactive or dormant means nothing is happening along this fault zone. In fact, the last movement along that fault line was 185 million years ago. So it used to be a fault line where we would see earthquakes and movement, but it has not moved in 185 million years. It is no longer active, so therefore it presents no future earthquake concerns. But it is across Georgia, and 185 million years ago, it did produce earthquakes, but now there has been no movement along that fault line, so that is not a threat to us. It does provide the area for the Chattahoochee to follow. So it follows along the Chattahoochee, goes through the Georgia Piedmont, and if you are going along the Chattahoochee or maybe along that fault line, you're going to see rocks at that fault, and they're sheared, they're fractured, they're pretty easy to see. So that would be an interesting little field trip once we're allowed to leave our homes to go along the fault line there and take a look at it. You'll see lots of really old rocks along that area. Now, as far as earthquakes in Georgia, the largest or strongest earthquake we've ever had was a 4.1 magnitude. And remember, I showed you it goes from 1 to 9. So 4.1 is the strongest one we've ever had. And that was in 1916. So that's before your mom and dads were even born. This was a very long time ago, more than 100 years ago. It was a 4.1 magnitude earthquake. So we don't get strong earthquakes here in Georgia. Oop, let me go back. There have been 36. I advanced too quickly. So let's get back to that other graphic. I got a little ahead of myself. So here we go. So the largest is a 4.1 magnitude earthquake. Oh, now we're tiny. Hold on. We're going to make this bigger for you. My apologies. We're going to have to go through these graphics. real quick. Again, earthquakes. So we see the before the earthquake, after the earthquake. We talk about the different magnitude of earthquakes. I'm going to go quickly past this. We talked about the Brevard fault line. Again, it's dormant. It last had movement 185 million years ago. Okay, so this is where we were. We've had about 36 earthquakes since 1974. So we've had quite a few, not a ton, but we've had some, but they've been very, very small. Most of them you don't even feel, and even if you do feel it, it's not going to cause any damage. So do we get earthquakes in Georgia? Yes, but they're not very strong, and it doesn't happen very often. And most of them are detected by seismograph, which is the instrument we use to detect earthquakes and see how strong they are. So that's how we even know there was an earthquake. Otherwise, many times we wouldn't even know exactly what it was. So today's trivia question, what is it called when earthquake, oh, and we didn't even talk about this. My apologies. We're going to talk about it now. What is it called when earthquakes create a giant wave in the ocean? Is it a rogue wave? Is it a taqueria? Is it a tsunami? Or is it a ripple? Does anybody know the answer? If you know the answer, write it down. We'll give you a minute. What is it called when earthquakes create a giant wave in the ocean? Dun, 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 dun. And the answer is, the answer C. So we talked about what happens with these plates as they go past each other or above or below each other. We use the example with this toy, but you can use Legos to kind of do it yourself. You can even do it with your hands. If you go like this, pull, 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 and it's that pressure when you release. But it is a tsunami. So when this happens, because we talked about the different placement of the plates, there's several plates that make up the world and the globe. But when it happens in the middle of the ocean, you get a tsunami. It creates a giant wave. And sometimes we have tsunami threats along coastal areas where there was a large earthquake. So not only can you have the damage from the actual earthquake, but you can have damage from a tsunami as well. So kind of a twofold. Also, volcanoes are a result of the plates shifting and moving as well. That's a different thing that can happen. So these plates moving and shifting do a lot of things across the globe, create islands as well. And there's actual scientists who study just the plate movements and the plate tectonics of the world because it really is an amazing phenomenon. We feel it in the weather world as an earthquake, but as well as volcanoes. And I'm going to do a separate lesson on volcanoes, also tsunamis, which we can do a separate lesson on tsunamis, and even a separate lesson on island formation, because islands form from these plates rubbing up against each other. So a lot of science goes into this, and a lot of geosciences as well. So I'm happy to answer any questions that you may have about earthquakes. Maybe if you've been through an earthquake, you can tell your little story there as well, and I'll go back and read it. Tell me about what it felt like when it was shaking. Personally, I've been in a couple earthquakes here in Georgia. They were very light. One happened actually when I was in the studio during the morning show when I was on mornings, and everyone was like, what was that? And by the time you realized it was an earthquake, it was over. It was a very, very small earthquake. I was in South America. I'm originally from South America. My family is in Argentina, and I felt a much stronger earthquake there, but I was also at the very top of a very tall building. So you definitely felt the shaking there. Luckily, I've never been in a really strong, powerful earthquake, but I can imagine it would be incredibly scary. So it is scary. Those who deal with it all the time, like those from California, they're used to it, unfortunately. They see it a lot. They feel it a lot. They don't get huge earthquakes, but from time to time they can. And certainly those are really scary because things start falling off shelves and the bed starts shaking and you see things falling from the walls if you have pictures on the walls. But luckily, we don't get strong enough earthquakes in Georgia for things like that to happen. And really, we haven't ever. Again, the strongest we've ever had is a 4.1 magnitude earthquake. Tim, do we have any questions from anybody today? And I think my phone cut out. I have terrible cell phone reception. Let me see. He's texting me. Oh, all the questions have been answered. Thank you. See, my cell went out. See, working from home is difficult. I'm sure you know, because my cell phone reception is terrible. Anyways, I'm so happy to talk about earthquakes today. Tomorrow, we are talking about snow and the different types of snow and the difference between snow, sleet, and freezing rain. So make sure you join us tomorrow at 1:15 for the World of Weather. I hope you've learned loved learning about earthquakes. It's a tongue twister here. And if you don't own a globe, moms and dads, this is a great tool. I've felt you can learn a lot just by studying the globe, not only geography, but you can learn, you can use it a lot to explain a lot of things that the kids are learning about in school. So the globe has been very useful. Definitely recommend that everyone has a globe in their house. And geography is very important as well, especially my career. I love geography, so it goes hand in hand. Everyone have a great Thursday. I hope you're staying safe, that everyone's healthy, and everyone's enjoying learning at home. We'll see you back here tomorrow at 1:15 for another lesson in the world of weather.